Okay, give me 10 minutes. I'm going to teach you about solutions. This is the third and final video in our series on pure substances and mixtures, on elements, compounds, and mixtures. And solutions have come last because they're sort of the ultimate mixture. Now, I'm going to go fairly deeply into explaining what I mean by that, because a lot of people don't quite understand what a solution is. It's one of those words that people know but don't quite get. So here's what a solution is. Right? It's one substance dissolved in another. Right? The substance that's dissolved is usually a solid, and the substance that it's dissolved in is usually a liquid. And we're going to only deal with solids dissolved in liquids, mainly water. Right? But what does that mean? Right? A lot of people know the word dissolved, but they don't quite understand exactly what it means. It has a specific scientific meaning. So let me sort of unpack dissolved for you. If I was having porridge for breakfast and I wanted to put some sugar in my porridge, right, I could just grab a few of these guys, right? Lumps of sugar, sugar cubes, and I could just like throw 3 of them into the bowl. And that would be a mixture, right? I would be able to, it would be a mixture of porridge and sugar, but it wouldn't be much of a mixture if I didn't break those things up, right? It'd just be 3 big cubes of sugar floating on a bowl of porridge. And if I grabbed a spoonful of porridge, I might get 1 spoonful of porridge that's not sweetened at all because I've missed out on all the sugar. And the next spoonful of porridge, all I'm tasting is the cube that I got. So it would be a mixture, but it wouldn't be much of a mixture. Now I could do a lot better than that if I use this, right? This is sugar as well, but this has just been broken down into small crystals. If I put that into my porridge, that'd be a lot more easy to mix because each piece is so much smaller and there are so many more of them. So if I stirred that into my porridge, it'd be a much more even mixture and the sweetness would go pretty much through the whole thing. But you can go further than that. What if you crushed these guys up and made them even smaller? Right? Well, I did that. I just got a mortar and pestle and I got some of these and ground them up into a powder. And this is what it looks like. That is crushed up bits of this, right? And this is so small that the individual pieces are too small to see with the naked eye, right? This is really tiny. This is like talcum powder. It feels like baby powder, but that's sugar. And if I put that into my porridge and gave that a stir, that would be a beautiful, even, blended mixture because there are so many of those pieces of sugar to go around and each of them is so small. It'd be a fantastic mixture. The point I'm making is that the smaller the pieces in a mixture are, the better the mixture gets mixed, right? And the extreme version of that is a solution. Right? Now, what if I took this cube and actually dissolved it in water? Right? This is the ultimate way to break it down into small bits. Right? You've just seen me crush some of it, but if you dissolve this, the parts that it turns into are as small as they could possibly be. So I want to sort of show you this on a microscopic basis. If we could zoom in on that little tiny corner, if we had a microscope and could look at the particles that are just in that corner of it, it would look something like this. Just give me a second here. Oops, there you go. Just had to move a few things around. Okay. So let's just call this an extreme close-up of the very bottom corner of that big sugar cube. Right? So on this scale, if this is the size of the particles, the whole sugar cube would be bigger than your house. Right? So we're right down on the tiny bottom corner. Right? This is what happens when something dissolves. If we put this in water, particles one by one start coming off. Right? And they get surrounded by the water that they're in. Right? So they can't touch each other. Right? It's important, the fact that they can't touch each other. So this is a sugar cube that has just begun to dissolve. Now, if you stir the water, it dissolves a lot faster because that basically gets these guys out of the way. The water just goes and they're gone and there's space for some more to come out. So it's absolutely true that if you stir something, it dissolves a lot faster. Right? So when it dissolves, it doesn't end up like this. Right? This is not a solution. If this is in water, just assume that the white stuff is just a background of water, that we're looking at underwater pictures here. Right? That's not a solution. That would be a suspension. That's a bit like the milk that we had in the previous video. Remember this guy? Right? So that's not yet a solution. It's a suspension. Right? So when you dissolve something, it goes a lot further than that. That's still pretty small. That's microscopically small. You're never going to see those. And you're certainly going to taste them if they're sugar, but it isn't dissolved yet. Right? That's not dissolved either. That is. Right? When you dissolve something, you pull it apart as much as you can possibly pull it apart until every single particle is not touching any others. It's not a group of 6, it's not a group of 50, whatever that is. They're groups of 1. That is absolutely as small as particles could possibly get, and that's what a solution is, right? A solution is a solid dissolved in a liquid, and when the solid is dissolved, every single one of its particles is now all by itself. It has been torn apart into as many pieces as possible, right? So that's what a solution is. It's the most mixed mixture you could possibly imagine. Now I have to get you used to 3 new words here. Right? This is science word time. Stay with me. Whoops, I'm sorry. Okay. This is something that dissolves. This is a little blue powder. It's called copper sulfate. Doesn't matter what it's called, but this stuff happens to be called copper sulfate. And when you dissolve it, because it's blue, it turns the water blue. So this is a particularly handy thing to show solutions with, because it actually changes color and you can see how strong a solution is. So if you put a tiny little bit of this into some water and gave it a stir, you'd end up with something like this, right? That's a weak solution, right? Water that's just gone a little bit on the blue side because we've taken a pinch of that, put it in there, given it a stir, and it dissolves. So all of the pieces of copper sulfate are now like this, completely separated, and collectively they make that look blue. Now if you put a lot of it in there, right, you can put a lot more in yet. If you put a lot of it in there, it just makes it go darker blue. Now we typically call that a weak solution and a strong solution. Most people would call that, weak cordial, strong cordial, etc., right? And people, we all know what that means. We know that there's more of it in there and it's more crowded up together, right? That's what a strong solution of something is, right? But the sciencey words are dilute and concentrated. Concentrated makes sense. You've heard that before. When something's concentrated, it's all jammed in together in a small place, all right? And these guys, and these molecules are jammed in together very close to each other. They're not touching each other, because if they were touching each other, it wouldn't be a solution, right? They have to be all apart, but they're pretty darn close, right? There's not much room left, right? Over here, plenty of room left, right? There's not much of this in there, and so that's a nice dilute solution. It's a weak solution. Things are spread thinly. There's one more word. This is a fairly short video, this one. There has to be a limit as to how much of something can be dissolved in there, right? Like I said, this is getting pretty full, right? There's not a lot of space in here for any more of these particles to fit before they start touching each other again and maybe end up like this, and that wouldn't be a solution. So there's a limit to how many of these are going to fit in a given amount of water, right? You couldn't possibly dissolve a truckload of sugar, for example, in a bathtub, right? So if we kept on getting more and more of this into there, eventually we would put another teaspoon of it in there and stir it, and that last teaspoon wouldn't dissolve because the water is already holding as much as it could possibly hold, right? At which point it would be full. And there's a word for that as well. When a solution is absolutely full, and we know this one is, we call it saturated. The reason I know this one is full is because I can see the extra solid copper sulfate sitting on the bottom, unable to dissolve because there's just no room left. All right? So there are 3 words to describe the different strengths of solution. Dilute is pretty weak, right? Not much of the solid in there. Concentrated is strong, and saturated is absolutely full. Now there are 2 words left. The stuff that you put in is called the solute. The water that dissolves it is called the solvent. When you put them together, you make a solution, all right? So the solute goes into the solvent. Now, the reason I've underlined the U and the V is because these 2 words are sort of in alphabetical order, right? The solid goes into the liquid, the solute goes into the solvent, all right? So if somebody says add more solvent to this, they don't mean add any more of that. They mean throw in some more water, right? So you've got 5 words to understand, right, that might turn up in a test, right? And you have to know what we're talking about if we say these words. Solute, solvent, dilute, concentrated, and saturated. Know that and understand this, and you have just become a solutions expert. Well done.